Hey there. So this is the first video that I've put together for chapter 6. So we're going to begin that chapter and you can just read through those targets yourself. First thing I want to do is just review questions 571 through 574, and then we'll get started on chapter 6. All right, so first things first, I know this is a little bit hard to see, so if you had your own ebook, that might help, but what I've done is I've just copied and pasted the question and then the answer. You could also pause the video and look back at your own homework if you can't remember what your answers were, but I've already skimmed through it. You guys look like you did a really good job, and expect to see some grades there in the next day or two. All right, so the first one was to take a look at that sequence. It's way over to the right here, -8, -2, 4, and 10. And they asked you a couple of ways you could find the 10th term. So you can see you could use the equation, or you could just keep adding until you get to the 10th term, and the answer there was 46. The equation itself is t of n is equal to 6n minus 14. If you were using slope-intercept, you would say y is equal to 6x minus 14, but just replace the y with t of n and replace the x with n. And then in terms of the recursive equation, if you take a look here, all you need to know is the slope to write a recursive equation. This just tells you you add 6 to each term to get the next one. So t of n plus 1 is t of n plus 6. Right? Hopefully that makes sense. All right, moving on to 572. So Alejandro used that equation to write the following sequence, 0, 6, 12, 18, and 24. And technically that recursive equation does work there. But you can see that the recursive equation itself does not really give you the sequence. So the sequence doesn't match. So how could he get a different one? Well, he would have to know that the first term was -8. All right, so basically he used the first term as 0. Technically, term 0 is the important one. That's the one that you should really focus on. So t of 0 is -14. All right, so he just didn't start in the same place, that's all. All right, for 573, I got a few questions on this one, and I'm really glad to answer questions. Please email me. Hopefully my answers made sense. Sometimes it's hard when you're emailing to, really help people out. If you're really stuck and you wanted to, we could set up a time to do a Google Meets, and I can talk to you about how to do that. Okay, but this equation, the first one is recursive. So t of n plus 1 is taking t of n and squaring it and then subtracting 1. So you can see down here, if the first term is 3, we're going to do 3 squared, which is 9, minus 1 to get 8. 8 squared, which is 64, minus 1 to get 63. And then 63 squared is 3,969 minus 1, which is 3,968. This sequence is neither arithmetic nor geometric. You can explain it like this. You're not just adding to get each term, and you're also not just multiplying to get each term. If that's the case, it's something different. In this case, it's quadratic. We will be getting to quadratics later, but for now, just know it's not arithmetic or geometric. For this one, he'd have to actually figure out everything up to the 10th term, and I started trying to figure it out. It is a huge number, so I just am like, I'm not going to bother. I would have gone into scientific notation, and maybe at some other point we'll do that, but it was a huge number. Okay, so 574. These two questions are not related, which to be honest made me a little confused at first, but it's all right. All right, so Colin wrote the second term as 19, and t of n plus 1 is t of n minus 2. So that means each time you go up 1, you subtract 2. So I would say this is the slope. It says to help Avery write an explicit equation. So right here, this 23, that's t of 0. That's going to be the y-intercept. So they wrote it kind of backwards. I wrote mine as -tn plus 23. Slope is -2. All right. But anyway, they wrote it as t of n is equal to 23 minus 2n. It's an arithmetic sequence because you add -2 each time. For B, Avery wrote this, which is an explicit equation. Colin's writing a recursive equation. Remember, all you need is the slope, which is 6. So that tells you just add 6 each time. So basically, T of n plus 1 is equal to T of n plus 6. I don't know why they have T of 1 is equal to 14 here. I didn't really think that was important. So if you did not have that, that's okay. I'm not sure why they asked for that or what that was all about. Okay, so there's the homework. If you have questions, email me. All right, let's take a look at this though. All right, we're going to start chapter 6. All right, and I'm going to want you to read through the opening yourself. So that's one thing I'm going to put on a Google Doc that I want you to work on. So read through that, but I want to point out just a few things that are going to be coming up, and then just a couple little diagrams I put here. This chapter is really beginning statistics. What I like about this chapter is you can start to see how algebra and working on linear equations and exponential equations and all of that is actually used in the real world. I am convinced that some of you are going to have jobs that require you to write equations. You might be in some sort of science field or some sort of statistics field or maybe economics. You are going to have to use what you're learning now about writing linear and exponential equations in your job, if that's the case. So what we're going to be working on here is line of best fit, which we've started, but then we're going to get a little bit more sophisticated with line of best fit. So is it really the line of best fit? How do we know? We'll be talking about residuals. There's a little picture over here of residuals just to the right of my picture. A residual is really the difference between your line of fit and the predicted value on your line of fit and the measured value, right? And then there are ways that we sort of average them together to see how good the line of best fit is. And we square them when we get to this. I don't want to say much more about that, but we'll be getting to that later. So residuals, how far away is your line from the actual? All right. We'll be talking about least squares regression lines. That is truly finding the line of best fit. In this unit, you're going to be using Desmos Graphing Calculator a lot. You are not going to be expected to do this on your own. You're going to use tools that are already there for you. I might share with you just a few formulas about how statisticians get these, but the beauty of this is that the computers do it for you. All right, we're going to do some residual plots, which tells you specifically how far away your line is from the actual data, what's the best data. We'll talk about something called correlation coefficients. And then I mentioned that we were squaring some things. We're going to talk about what R squared means. Don't worry about any of this, all right? I'll be teaching this to you as we go along. The important thing is we're starting right here with line of best fit, and you already know a little bit about doing that. All right, so right here, all right, this is going to be your task. And today, instead of giving you questions throughout the video, basically I'm just explaining it, and then you're going to do some book work. So your assignment from 611 really has to do with a guy named Robbie, right? So I'm sure you've read through this while I've been talking, but Robbie cannot get a ticket into a football game that he really wants to see. So what happens is he finds a drainage pipe. Now there's a little picture of this in your book, so I'm going to want you to look at that, but here's the drainage pipe right here. So his plan is to try to watch the game through the drainage pipe. Problem is, right now, he doesn't know how much of the field he can see. So, basically, we're going to help him out here. So this is sort of like looking through the drainage pipe. I actually used a paper towel tube, and this is a picture of my shed. So what it looks like looking through this, and I could see very little of the shed from where I was standing, but as you move further back, your field of view gets wider, so you can see more. So that's what we're going to be working on. We're going to figure out how much of the field he can actually see through the drain pipe. All right, so we were going to collect some data on our own. I had this all ready to go for school, and then things just got really crazy in this world. But you can see there's a picture of some teachers doing this. I was actually going to give everyone the same size tube to look through. And basically what happens is, and these are a bunch of teachers doing it, the teachers or students would measure the distance from the end of the drain pipe to the wall. And then these two people here are listening to this woman and saying, okay, how far can you see? And she's letting them know, okay, I can see, all right, that's the left side, this is the right side. And then they're measuring. So this would be the field of view. And as she backs up further, she can see more. So we were going to collect some data on that and see how far apart our data was. All right, but I just wanted you to get the idea of how this data is collected. Okay, so because this really does take a group of people to do, and I'm not convinced that everybody's going to have a group of people who would want to do something like this. We're going to use this data, and this actually came in the book. If for some reason you can't do this, which is us, basically they want you to use this data for the basically for your field of view. All right, so you may need to stop the video and write this down. I will actually put this in a document, though, that I'm putting on Google Docs, right? And the great thing about us all using the same data is that we can get the same answers, too. All right? If we had done this on our own, we all would have had some different answers. We would have had to talk about that. All right, one question in today's work asks you to describe an association. We talked about this before. This comes, and this is why we reviewed it in a previous video. This comes from section 4.2.1. So it would be great if you can't see this. I can understand it's way too small, but just turn back to that section. It's the math notes and read through this because you're going to be asked to describe an association. And please use 3 words to do so. Say whether it's negative or positive, say whether it's linear or non-linear, and say whether it's strong, moderate, or weak. Okay, so here's your task, and I'm going to be putting this up in Google Classroom. I want you to make your best effort. I don't want you to be frustrated, though. All right, so with these core problems and even the homework problem, I'm going to be posting answers. I'm also just an email away. All right, so jot me an email. If you get totally stuck, I'm okay with you waiting. So I'm going to be putting up a video explaining the answers, how we got them, and I'll post that video tomorrow. I just wanted to talk to you about the graph. I really want you to use Desmos Graphing Calculator to do this. All right, I'm going to move this my face over here. So then what I'd like you to do is then just copy and paste the graph into your work. And I believe it's Shift Control 4 to take a snapshot or just take a clip out of a picture. Please use Desmos. All right, don't try to graph this by hand. The Desmos Graphing Calculator will graph it for you. You just plug this table in. If you need a review on how to do that, just drop me an email. All right, but use Desmos, please. All right, and then here's a couple of ways to get in touch with me. I just wanted to say this. If you do write a comment in Google Classroom, just please know that everyone will see that comment. That is public. So that's fine. I mean, and if you ask me a question in Google Classroom, I'm going to answer it in Google Classroom. Like I'm going to answer it publicly, because a lot of times if you have a question, other people have the same question. And I just want everyone to see how I respond. Okay, so just know that. But I know some people don't like their questions to be public. If that's the case, just drop me an email. And I've got my email address right there. And if you're really stuck, and you really want to have a conversation with me, I'm cool with that too. We'll just do it via Google Meets or Zoom. Okay? All right. Thanks everybody, and good luck.